All right, welcome back. We are Game 2014 in the fall 2021 semester at George Brown. It's Mobile Game Development 1. It's week 5, part 1 of our broadcast. And there's a couple things we need to talk about today. One of them is where we're sitting. We're sitting at week 5. We're talking about optimization for mobile. And today's lab, or this week's lab, is going to be object pooling. We're revisiting this. This is not something new. This is something that we're going to be looking at again from pretty much the first year. I think most of you had object pooling from from year 1, and now we're just going to do it all over again. All right, but we're going to do it with Unity. A couple things to note from this week's activities. Assignment 1 part 2 was released, and it's due week 7, so that's why this little mark is here. I was reminded of that. It's actually due not the week we come back from break, but actually the week after that. Next week, we don't have week 6. Next week is actually a break. Our mid-semester break happens on next week, not here. So that's when we have our break. Next week is Thanksgiving week, as an example. Am I right? Wait a minute. No, next week is a shortened week for you guys. I'll be okay. Next week we have a week. It's just that we won't see each other no. We were going to have intercession week in week 7. So I'll be okay after week 7. And so next week is a shortened week. There's no school on Monday for you guys because next week Monday is Thanksgiving, and so you guys won't be here. But we're still going to meet next week on the Tuesday, which is totally cool. So next week Tuesday. But as a result, we've moved our assignment 1 part 2 to week 7, not week 6. So that's why it shows week 7 on our stuff, right? We've already had our makeup class for next week's multiplayer dev. Cool. That's awesome. All right, so that's what's happening for next week. So that's why we're moving our assignment 1 part 2 to week 7. Let's move on. So lab 3 this week has been released and is due this week Friday, and it's all around object pooling. Test 1 results were very good. They're about 85% in terms of your average, thereabouts, give or take some. There's some people that actually did very well, closer to 100%, but some people also pulled us down, the people that did zeros, and the people that did very poorly, they didn't study, or I don't know why, but they didn't look at it, but they pulled us down to 85, but there's a lot of numbers that are way up there, a large number that is over 90. Okay, so UML is what we're going to be starting to talk about first, a little bit, and then we're going to start talking about design patterns, what they are, the object pooling design pattern. We're going to talk about Unity game objects and how they work, as well as an object pooling demo. So very, very straightforward today. Let's get moving on. What is UML? It's a uniform modeling language that we've seen before. And let's take a look at a tool that I recommend called StarUML. So I've kind of shared this link, StarUML, with you. So please, if you haven't had a chance to go up and download this, download it now. All right, and what StarUML does is it's just a tool to visualize what classes look like. Okay, so I'm going to bring up StarUML for myself. There it is. And if you notice, when I bring mine up, I have a what looks like a unregistered version. That's okay. We're students. We're just going to use this to evaluate. If you like it, though, and it's really useful to you, you can buy it. So what is this tool? Why am I bringing this tool up? Well, we're going to see a lot of different classes over the next little while, and sometimes what we'll see is a description of what the class would look like, and without understanding what UML is, then you may be confused when we see diagrams. Okay, now you should have already covered UML. Yes, did you? Check mark if you've covered UML before. X if you haven't. Semester 1, awesome. So this is a review of what it looks like. So on the left for this tool, this is new. I want to click on a class, and if I kind of click anywhere in my canvas here, then I can kind of put in the class name. Let's suppose it's the person class. This is kind of cool. And what you can do with the person class is the first box, as a reminder, is what the name of the class is. The second box is where the attributes or instance variables are, and the third box is where the functions are. Okay, so if I right-click and add an attribute, I can rename it. On the right, it's a context-sensitive menu. Notice that there's also a structure for the person model, the class itself. And attribute is the name. We want to make it so it's more descriptive, so we'll just use the name. We can also suggest the type. So the type would be obviously a string of some kind. So there's a string for the type. And we probably want to make our instance variables or attributes private to adhere with the object-oriented programming methodology structure, right? So name string is private. Private is a negative sign or a minus. Okay, let's add another one, another attribute here, and this attribute will be called age. We've seen this kind of example before. Age would be private, and we say that the type is an integer because we don't type, we don't say like I'm, 35.7 years old. We don't do that. Okay, so, and then what you can do is StarUML has a bunch of tools that you can download. You can go to Extension Manager for StarUML. And there's two extensions that you need for this one. The first extension, if you scroll down, is the C# code generation and reverse engineering extension. So please install this one, okay? And the other one that we want to use, if you scroll down, is I want to use one that says generate getters and setters. So I want to install that one as well. So those two, okay? You may need to reboot your StarUML, but what this does, generate getters and setters, is if I kind of select both the name and the age attributes, and if I go to tools and if I go to generate getters and setters, it does some of the heavy lifting for me. It generates the name and age getters and setters. Nice, nice, nice. And then what I can do is if I want to add an attribute, like for example, hey, some kind of behavior that the person does, because the person is a class. Classes have data members. They have some kind of accessors and mutators. Accessors being the getters and mutators being the setters. And then what I want to do is I can also have behaviors. Let's add a operation is what they're called. And the operation I can specify here as something like a person says hello. Right? But the says hello, you can be more specific. You can say, what is the return type? Now, there is no return type that you can see here, but what you can do with StarUML is you can right click and add a parameter. And the parameter, what you can do is you can wipe it out. So you don't have to see the name of the parameter at all. So delete it. And then you can still specify the type. So let's say, for example, the type is void, right? And then what I can do is the direction is a return. So it's a return type, right? So it says hello, returns void. That's what this basically says. Notice on the right-hand side, I have my structure, and I can also revamp my title or my untitled project. I can change this to the name of the project. For example, GAME2014 in the fall 2021 semester, and it's week 5, right? And I can say the author is me, and company is George Brown, and copyright is 2021. You can be very specific in terms of stuff, and my version 0.0.1, right, from my type, my person class. Yay, awesome. And then what I can do is I can add another class, right? And a couple ways to do that. I can add just another class by pulling it over again, or if I double click on an existing class, then I can specify here a subclass or a child class. They're called different things, derived class. So if I do that, if I click this button, I get this child class with an arrow that points to my person class, and I can rename them to something like student, right? The student is similar to the person. I can add an attribute, but they have a special attribute called the student ID. Make it lowercase. Student ID, and the student ID also would be private, and maybe is also of type string, right? So there we go, string type. And what I can do is I can generate a getter and setter for this, okay? And I can also have a special function that the student does, because remember how we work with classes. Classes and object work like this. Classes, the parent classes, a review of classes, are leaner, if you will, than the children. The children actually are fatter from a memory footprint perspective because they include everything that's included in the parents, including the attributes and the functions, as well as the memory footprint. So the memory footprint is whatever the parent class is worth in terms of total memory for all the attributes and what it's worth. And then we add specialization, the student attribute, as well as a couple of getters and setters, which makes immediately that the student is just fatter or bigger from a memory perspective than the parent, right? Which is the person. So children always fatter than the parents, right? Which is kind of the challenge when we use inheritance. Let's add a new operation here. A student will study. So studies is the operation. And again, what we want to do is we want to return types. We can add a parameter just like we did before. This is just to show you again one more time. The parameter on the right, we can kind of wipe out. And we can say that the return type is void. We're typing that in. And then the direction is return. So now again, studies returns void. Nice, awesome. So we can see that this is a structure. And what this should do for you is when you look at this structure, you should understand, as an example, what's happening. So I have two classes, a person class, which is a superclass, the parent class, the base class. Different things mean the same things. Those are all the same. They refer to the same thing, okay? And we have the student class, which is a child of the person, or a derived class, or a subclass. They all mean the same thing, okay, for the most part. Depending on the language, you might hear different terminology used for object-oriented programming, but the idea, the concept is the exact same, okay? Questions around this? Is it clear? If I showed you classes that look like this, do you understand what they mean? Plus, again, means public. Minus means private. And if I wanted to make the person class abstract, right, which means chances are I'm not going to make an object of type person because no one is just a person without some form of specialization. I probably am a student or a professor or something else. And I can even go further and I can make a further specialization of student, and let's call them international student. I'm not going to describe everything, but and we can also have a domestic student, right? So different kinds of student. Okay, so again, this describes a hierarchy of classes as an example, and it should be kind of, when you look at this, you should kind of understand. Okay, does anyone not understand how this works? How about that? I'll start with that. Or not getting it, what I'm trying to do here. I'm using UML because we're going to get into some kind of discussion about classes, about structures, and I want to be able to describe them with you live relative to what we're going to see. Also, in some future lesson or lab, I may ask you to use to add a UML diagram to describe your code. Okay, so Star UML. One thing that's great about Star UML is you can use the some tools to take this class. So let's say, for example, I go to Tools and I go to C# and I go Generate Code. I can actually generate C# code right from my diagram. So if I go to my model and I press OK, and if I choose a new folder, let's call this folder week 5 example. I've already done it for the previous class. And if I say select folder, and if I look in that folder, let's take a look at that folder now. You can see that inside the model folder itself, I have a bunch of stuff. I have person. I'm just going to double click here. And person will actually generate my code. It's been generated for me. There we go. As well as student, right? There's student, which extends the person superclass. And I have some stubs for international student, as well as domestic student. Okay, so all of those classes are ready to go. So it does some code generation for you. Nice? What do you think? So really quick, easy ways of generating code. And there's a lot of tools out there that can do this kind of stuff. You can draw a diagram of your classes, and then what you can do is you can generate the code for the classes that gives you kind of a starter to get going on building upon your architecture. Okay. How about the other way around? Well, if I close this off, so let's say, for example, I close this, I don't save, and I start StarUML again, and let's evaluate one more time. And I want to do the other way around. If I go Tools, C#, and I go Reverse Code, then I can choose Week 5 Example and click Select Folder. And now I've got them all back right here. So let's say, for example, I take my student class. There it is. And I take my person class. I can see that I have a relationship between student and person. And the same thing goes with domestic students as well as international students. So I can pull all those in and I can generate a diagram based off stuff that I already have, right? Heck, I can even take this further and let's generate a new diagram. I can take this further and let's use a something from today. I did kind of a thing with you guys today for the first group. I had in the first group, I used a lesson 3A, and in my assets, I have a scripts folder. Here's my scripts. And what if, I want to use these scripts, to pull in here as well? Can I do Unity by bringing these things in? Well, if I go to Tools, and if I go to C#, and if I go to Reverse Code, and I choose my desktop, and if I go to GBC, and if I look at GAME2014, and Lab 3A, and I specify my scripts folder and click Select Folder, well, it's amazing what it does for you, doesn't it? Let me bring in a class. For example, the one that I made, I kind of create a bounds class. There's a bounds struct, actually, is what it is, right? Now, one thing is it's not perfect. So notice that there's no attributes for my bounds, but then again, bounds is a struct, not a class. Let's bring in some other ones that I want to use. For example, something like my player behavior. If I bring my player behavior in, you can clearly see that this is the case here, right? And I can also bring in mono behavior, and it shows that player behavior is going to be inheriting from mono behavior, and you can see the structure here. So really cool, great way of showing your stuff by just dragging and dropping, right? So if you already have code, you can use it here. And same thing with, instead of just my player behavior, I also have enemy behavior. You can see that that is also something that I'm including here, right? As well as anything else that I've added in from before. So really good. So really excellent. And it shows you that they're both related to mono behavior. In the future, we're not going to just, they're not just going to inherit from mono behavior, but something else. Okay. Notice also that these kind of, little tildes here, if I click onto this, remember that I can click on anything to inspect it. It tells me what the visibility is, which is package, right? So it's a different kind of visibility than public, protected, or private. It's the entire package itself where update is available, right? Whereas my move function is a private function, and so is checkbounds. Okay, so that's something that we're going to be talking about today, but this is an example of how we can use StarUML or something else like that to describe the code that you're creating. All right, cool. Questions around StarUML and UML in general, unified uniform modeling language. Anybody? I know this isn't the most, I'll say, interesting part about programming, but programming, you need to be able to communicate with other programmers. And the idea with this is when it comes to StarUML and any kind of tool like that, whether it's StarUML or another modeling tool, right? The idea is we can communicate with each other and say, hey, this is this class, and you can start diagramming and architecting the class before there's one line of code, which is really the key here. Okay. All right, let's continue. So now that we have an understanding of how to describe a class with code, let's go into our lecture for today. Today's lecture is all around design patterns. So what are they? Well, we can think about design patterns as successful code that has been kind of developed over a long period of time. And usually design patterns are associated with object-oriented programming, right? So I'm just looking at Kira's comment here. Generate C# headers, but when I opened it in code, they were only named correctly. They didn't actually return what they were supposed to. I know they're not perfect, Kira. I know it's not quite perfect, but at least it gives you a starting point. So really, yeah. So we don't want to reinvent the wheel when we create patterns. We sometimes have the same problem that we want to try and solve. And we already have potentially a solution that's out there that someone else has gone into, right? And it actually has figured out. They figured out a solution for our problem. So why reinvent the wheel? Let's use something that's already out there. So hence design patterns. So really what a design pattern is, a proven solution by someone who's experienced, who's done this before, right? And apart from describing the problem and prescribing the solution, the design pattern will also kind of describe the implementation issues, any problems using it, or should you use this design pattern now or not? Is it an anti-pattern or something like that? Design patterns were first, especially for object-oriented programming, were first described in the very popular book, Design Patterns, Elements of Reusable Object-Oriented Software, written in 1994, at the time by the Gang of Four, Eric Gamma, Richard Helm, Ralph Johnson, and John Lycides, those four. And the Gang of Four kind of said, look, we noticed that there are approximately 23 design patterns that are out there that we can reuse over and over again. And we kind of keep on reinventing this. I keep on making the same design pattern over and over again. Why don't we just share this with everybody so that other people can kind of share in the wisdom that we've kind of figured out over the years of using object-oriented programming techniques. And so this book was born. What we use, which I recommend for us, is there is another book that we can go to, and it's called Game Programming Patterns. So Game Programming Patterns, you may have seen this book before. I know that we've talked about it before. Game Programming Patterns by Robert Nystrom. And this book is available in print as an ebook, in PDF, or free for the web. And if you look at the web, it describes many of the patterns, and they're broken down into different types of patterns. So some kind of structural patterns, sequencing patterns, behavioral patterns, optimization patterns, and so on. Okay. What we're interested today is the object pool pattern, and I'm using Robert Nystrom's work as a basis for some of the stuff we're talking about on the PowerPoint document. So going into this, so what about these optimization patterns? Why am I even talking about this as a first pattern for mobile? Well, remember we talked about this, that desktop hardware is still way better than a mobile device. From a hardware perspective, a mobile device is still quite limited in what it can do. And now in the future, we might not have that issue. Maybe in the future, in a near future actually, maybe in the next 5 years or so, we might have a handheld device that outstrips anything we have today as a PC. Again, with the chip shortages we're facing today, maybe not, but definitely let's say in the next 10 years. In the next 10 years, we'll have a handheld device that is better than anything we have, as an example, that's sitting on our desktop, let's just say. And then maybe our optimization requirements may not be as extreme as they are today. Today, a handheld device, smartphone as an example, or console, is still a lot more limited than for something that's on the desktop. Okay, that sits on our desks or whatever, right? Even laptops are more limited than a PC, a desktop PC or a Mac. So again, we sometimes need to optimize. And even if we didn't have hardware requirements, game applications are always more demanding, from a optimization perspective, because we do something every frame, usually 1/60th of a second or more. As we move into higher frame rates like 90, 120, and so on as a common frame rate for games, right? So we want to kind of do something, make calculations happen multiple times every second, which is way more demanding a lot of times than most average applications that you would create, let's say, for a bank or something else like that. So object pooling and optimization patterns in general are good all the time for games. There's nothing wrong with using them. So let's talk about the object pool really quickly. So what is an object pool? Let's think about a case for this, for the object pool, right? So I guess the intent would be we want to improve performance and memory use by reusing objects from a fixed pool instead of allocating and freeing them individually. So here's a common scenario. I want to have a bullet. I instantiate a bullet, and I instantiate a bunch of bullets at the same time. They fire, and then once they leave the screen, they're off screen, we destroy the bullet, as an example. And this is okay, but what about if I had a bullet hell shooter? What about if I was using a particle system or something like that, a homegrown particle system where I wanted to have thousands upon thousands of particles? When I instantiate and destroy stuff, it's computationally expensive. And what it does is it causes something called memory fragmentation. So it's better for us to do it in this scenario where we use object pooling, where instead of instantiating a bullet, I pull a bullet out of a pool, I put it into the place that I want it to be, it triggers, so we see it on the screen, and then when it leaves the screen, we pull it back into the pool. And so what we're doing is we're using object reuse as opposed to instantiating and destroying. So this is bad, this is better. Okay, now there's some issues with this. And one of the issues that we're going to have with this type of pattern is we need to be kind of predeterminate in terms of how many bullets we have set up in the pool ahead of time. So a good example of this would be, I need to know that I'm probably going to only need 50 bullets in the pool, and that'll be enough. And what I'm going to do is I'm going to pre-instantiate or create all the bullets that I need, right? So preload all the bullets, and after I've preloaded them all, then use them. And I'm going to have a steady state of memory as opposed to memory fragmentation. Okay, so that's the advantage. Disadvantage is, what if I have more and more and more? Then there must be some kind of way of dynamically allocating additional bullets when the bullet demand increases. Okay, still using a bullet pool, but I can increase the demand if I have many, many more objects in there. So there'll be some cases where I need to load more, but through testing, I could kind of figure out that maybe for a bullet hell shooter level, I need 500 bullets, 300 bullets, whatever the number is going to be. So again, the object pool, when we instantiate and destroy, we suffer something called the Curse of Fragmentation, which is when I instantiate stuff, this is as per Robert Nystrom's drawing, I love this drawing, you have a memory heap that is initially empty. I allocate memory, so I have a couple of objects, one that's smaller and one that's larger, and I have a memory page here, let's suppose. So when I delete my smaller object, it leaves a blank, an area that there's no memory, right? No memory usage. But my other object is still sitting in a specific memory location. And then when I want to add a new object that's the same size as the larger one, we can't use the same page, memory page, if you will, or memory area. And what we're left with is might have a fragment, a space in the front and a space in the end, and we have to allocate memory in another page. And over time, this creates fragmentation, which is non-optimal when it comes to usage. So again, one thing to note is that C# it does automatic garbage collection, but one thing it doesn't do necessarily is memory defragmentation. It doesn't do that. And sometimes writing something like a memory manager, custom memory manager in C# or in C++, it can help with memory management. When we do instantiation and destruction. Okay, sometimes we need to. For the most part, we want to avoid this situation. And if I pre-allocate all my bullets, I'm never going to destroy them. And therefore, my memory is going to be contiguous and it's going to be the same. The other problem with when it comes to memory allocation and destruction, the instantiation itself causes a bit of a slowdown. We're talking a very small amount. But when we have thousands upon thousands of objects being instantiated and then destroyed, it can cause quite a delay, or it can be quite computationally expensive, especially when the objects are being instantiated. Okay. So so you might have inconsistent performance. So again, the pattern is we want to define a pool class eventually, not this week. We want to define a pool class or a container where we can have a collection of reusable objects. And what we want to be able to do is we want to be able to bring them in, set them as active, as an example, or alive in this case that they're talking about. And then when we don't need them anymore, we set their state to inactive and put them back into the pool for reuse again. So we bring them out of the pool, use them by making them active, getting them out of the pool again, and making them inactive. Okay, so that's kind of the way we would do that. And we've done this again with SDL. When we were talking about bullet pools in the physics class we did together, we've done it in a number of ways. So when do we want to use it? When we frequently use or create and destroy objects. We want to be able to use object pool. Okay, the objects are a similar size. This is important. And when allocating objects in memory is slow and could lead to memory fragmentation, this is a good reason why we want to use this. And this is kind of our need, if you will. Okay, questions about object pooling. We've used them before. Any questions around the need? Do you think it's required? What about for mobile devices? Do you think it might be necessary for us to use object pools? What are your thoughts around that? You guys are programmers. Well, let's see what happens for those people who are, who don't know. So one thing I want to do now is I want to move to the technical piece, right? So remember last day we had a project that we were using called Lab 2. So GAME2014, F2021, Lab 2. We're going to make a new one called Lab 3. I've already done this. And last time what I did was I downloaded the previous Lab 1B from GitHub, and then I made kind of a copy and made Lab 2B. Instead of that, this time, I'm going to make a new folder. Let's do it a little differently to kind of use our tools differently. So a new folder, I'm going to start off with Game 2014 in the fall 2021 semester, and we're going to call this Lab 3B, okay? And what I want to do is I want to go into Lab 2B from last week, right, because I have it physically on my system, and I want to preserve a couple things. I want to keep my commits. So I don't want to just go onto GitHub and download the lab, and then I'll miss my commits. I won't have a history of what I'm doing. I want to keep all those things from last week. But what I don't want is my library folder or my builds folder. So what I can do is I can select all and then just deselect, control left click on my builds and my library. So I only have the stuff that I want to copy. And then let's control C to copy, then go back into my new folder and control V to paste. And you're going to see that it's pretty quick. Okay, so this is Lab 3B. Couple problems. One of them is that I'm missing my README files wrong, and there's a couple of other things that say Lab 2B and so on. We're going to fix this later on. So what I want to do here is I want to use Gitkraken, and with Gitkraken, I want to, instead of making a new repo like last time, I want to open a repo. So I want to open a repo, and I want to open a repository here, and I'm going to specify where I'm looking. So I'm going to look at the desktop, George Brown, Game 2014, Lab 3B, and press Select Folder. So what this is going to do is it's going to select my folder, and notice on the left that there's already a remote. My remote is pointing to, if I click on the origin remote, and if I go to Edit Origin, you can actually see where it's pointing. It's pointing to my Lab 2B. I don't want this, and I could edit it here. But I want to do it differently. I want to do it all in one. So instead of editing it, let's just remove it. So on the left where it says remote, in origin. I want to click on this little ellipses and click remove origin. No more origin. Alternatively, instead of doing it this way, what you could have done is go here to the terminal tab itself. So Gitkraken recently, it has a really good terminal. So if I actually click terminal, then you can actually see that it opens up a little terminal window here, okay, which is kind of cool. And what I can do is do something like a git, and if I press space, it gives me a list of commands that can help me do command line. So for people who are afraid or freaked out about command line can solve a lot of problems that your UI can't solve a lot of times. And so what you can do is you can say kind of git status, and it'll give you a status of what's happening. So say like, here's some stuff that is untracked. Here are some things that we are discarding, some stuff that we've been working on, some stage changes that are not staged, and it gives us some information about this. I can do anything that I can do here in my in the app. I can do it here in command line. So for example, if I wanted to say, let's clear this up. If I say git add dot, that adds everything to the staging area, right? And if I say something like git commit -m, and they'll say added or updated project, then I can do that and it'll keep track of my new commit. This is my new commit locally. So pretty cool. You can do all the command line loveliness you want to do right here. But right now, what we don't have is I don't have a repository online on GitHub that I can host it, right? So what I want to do is I want to push this up just like last time. And when I push it, it's going to say there is no remote. Do you want to add one? Yes, I do. I can specify where I want to add the repository, and it can be the name of the repository that I'm working on right now. Create remote and push local references, just like before. Or I could have done this in terminal. I could have gone in terminal and say, git, push. I can make the reference. I can go up on create my GitHub repository first, come back down and get the remote, and actually use terminal to add the remote manually. Either way, right now we have a new project. It's called GAME2014 F2021 Lab 3B. And for those people who are just kind of here and you weren't here last week, or you missed something, you can always go up on George Brown and download this Lab 3B right now as a starter. Okay. So here's the starter for today. Just putting it in the chat. One thing we need to do with the starter is I need to change this. So instead of Lab 2B, it should say 3B. Right, that's the thing that I want to do, and commit changes. When I do this, then locally I'm behind one commit. If I do a fetch, you can see that I'm out of sync. So the main branch locally is behind the remote branch on GitHub, and I can just do a pull to resolve that issue. Now I'm in sync again. All right, so there is Lab 3B as a starter. Let's bring this up on Unity. So back to Unity. Here's Unity Hub. I want to open a new repository. I want to go to my desktop. I want to go to GBC, GAME2014. I want to look at Lab 3B and click Select Folder. And now this is going to open up my project in Unity. Okay, questions so far about Git, what I did with Gitkraken. I wanted to do a different way, and I want to show you how to keep your commits. Sometimes when you work from one project, let's say, for example, you're working on assignment 1, part 1, and now you're moving on to assignment 1, part 2, and you want to keep the commits from part 1, and you want to keep that separate, that project separate than part 2, you can do that, and you can do it this way. Not seeing the git.git file in my folder. You mean the .git folder. And the reason why you're not seeing it, Nathan, is it's hidden by default. So when you see this right here, the only way you can see this is if you go to View, the View menu, and you must check hidden folders, hidden items, and file extensions. You need to click these two on. If I don't do that, let's say if I say, for example, I don't see file extensions, then that might not be good. If I uncheck hidden items, then I don't see .git. But meanwhile, it's actually there. Okay. Any other questions around that? Again, this is based on last week's, if you had last week's project on your system, right? If you're just downloading it from GitHub, you won't see .git. If you just download the zip archive. Because there is no .git, there's no Git archive at all. No, it's not an issue for me. As long as I get the stuff for you, Kira, I'm good to go. All right, so now that I have this and I'm up and running, let's change my layout. And what I want to do is I want to go into portrait layout for today, because this is the example we're going to use. So portrait layout. Okay. And I have a, up on Blackboard, I've shared with you some content, some sprite assets that we can use for today's tech demo. All right, so go up on the sprite assets. Please download these sprite assets. I've already done this. So if we take a look at the sprite assets, for me, it's under my downloads folder. And here they are. There are some sprite assets for what we're going to be using. And what I'm going to do is I'm going to bring up Unity, and I'm going to make a brand new folder in my Unity project. And the Unity folder is going to be called Sprites. I'm going to double click in there. And I'm going to drag and drop all the sprites that I have from here, right? By the way, you can also look at them as a detail view as opposed to what I did before. I can kind of drag and drop from these things into here, into Unity, and then it's going to import them automatically. You can alternatively, you can go to assets, and if I want to import, I can import assets this way too. So I can kind of specify where I want my assets to be. So if I, for example, if I'm in my downloads folder, I can specify inside of here, and I can kind of select all these assets and import them this way. That's two ways. All right, so I want to first set up a player, and I want to make a small game. It's going to be a space game, right? So let's bring my pixel player ship in here. What I noticed in our last demo is that right now our pixel player ship is 100 pixels per unit, which is pretty small, right? And that's inside of an untitled scene. Let's undo that change. Let's go back into the main scene, please. So in the main scene, there we go. If I bring in my sprite, my pixel player ship, it's pretty small. And I also have these buttons, which I don't need. Let's get rid of the buttons. I should just get rid of the whole canvas for now. So no more canvas. And my ship is really small. I'd like to make it bigger. And what I found is, from a sprite perspective, the right numbers are something like pixels per unit 50. We want to make it as pixel perfect as possible. So what I want to do is on the right where it says filter mode, instead of bilinear, we want to say point no filter. And where it says compression, I want to just choose none. So no compression, and click apply. And what this does is it makes it more pixel perfect. Ship. And that's the player ship. Let's rename the player ship to player. And let's bring down the player ship here to the bottom of my screen, which is approximately at -4. Okay, so this is where I want to bring it. So that's the player ship. The background should be black for this example. So let's go with solid color black. Okay, so there's a black background. And what I want to do now is implement player movement. For this, I need a new script. Let's call this one day, when it actually allows me to do it. Wow, that was weird. New C# script, and we'll call this player behavior. There we go. And player behavior, I'm going to double click. It's going to bring up Visual Studio. And under Visual Studio here, I'm going to have a script that is derived from mono behavior for my player, and I want to really work on movement. Okay, that's what I really want to work on at this point. First of all, before I continue, are you with me? Are you good? Check mark if you're with me, X if you're not. I want to talk about this so that way we're good to go. So Christian's good. Herman's not. Herman, what's going on? Am I too fast, Herman, or what's happening? A bit behind. Okay. All right. Nathan says, my git cracking messed up, so I had to push the initial file by bash. Just getting caught up. Okay. I'll go a little slow. So what I want to start defining here is a couple of things. I want to move my player to the left and to the right. Let's go back to Unity. So I want to move my player left of the screen to the right of the screen. And I want to use my keyboard input for today, right? I'm going to use physics today. I'm going to use physics today. So I'm going to show you, I'm going to do the physics way today. But yeah, there are other ways. You can use point-based movement. I don't recommend as much. And I recommend making your own, but I usually use physics-based controllers as well because it allows me to push the player to the right and left. And it's okay to use a physics-based controller as long as, for your assignment 1, part 2, as long as it doesn't jump. You're not using it for platforming or anything like that. And it satisfies the requirements of your game. I'm okay. But it shouldn't use physics like gravity. That's out of scope from what we're doing. Okay? I'm not going to be using gravity here, so I'm just going to be using the rigid body 2D for collision detection as well as for movement, just moving right and left. So on that, what I want to do is think about this object. It's going to move to a maximum here. I don't want the player to move beyond the left side or the right side. I don't want this possibility where the player can kind of hide half off the screen with your finger. So imagine if you have your finger on top of this, moving, not a left arrow or right arrow or A and D, and I can move and hide. I don't want this possibility. I want it to go minimum here and maximum there. Okay, so that's kind of something that I want to do. That's one requirement. I want to use physics to push the object or my player to the right and to the left. I want to be able to do that. So a couple things to do. Let's go back to code and start thinking about how to do this kind of stuff. So one thing I want to do here in my class is start defining a section for player movement. And I can use something called a header, all right? And I can say that the header is called player movement, which is going to kind of head off all variables, if you will, public variables that are going to exist inside there. I want to use a rigid body. So let's think about that rigid body first. That is going to be private. I don't need to expose the rigid body, but we need to get access to the rigid body 2D from the player when I add one, and it's going to be called rigid body 2D. That's the way I'm going to make sure that the object moves around the screen with a rigid body. Okay. The other thing is that I want some kind of horizontal force, public float, a horizontal force that I can push the player around with. That's what I want to be able to do. Okay. So those are the two things I want to start off with right now. When I have my rigid body 2D, I want to say that my rigid body is equal to get component when I add it in my rigid body 2D. Okay, so that's something that I want my player to be able to find its rigid body 2D when I do this. So because I don't have my rigid body 2D right now, let's add a rigid body 2D to the player object. So add component, we'll say rigid body 2D. We got to be careful here because if I add a rigid body 2D, it's going to fall. So let's do a couple things in constraints for the rigid body 2D. We're going to freeze rotation on the z-axis. We don't want my player object to spin. And what I also want to do is I don't want my object to go up and down. My player will not be able to move up and down. Just like the old video games, the player is going to be locked onto the bottom portion of my screen. Also, I don't want the user to be able to rotate their screen. It's going to stay in portrait mode. So going back, And back to this. So -4 is where the player is going to start for now. I want to freeze my position on the y-axis. So even if I have mass, it's not going to fall. But I'm going to allow physics happening on the x-axis, only across one axis. Okay, that's what I'm going to start off with. So because I'm not going to allow that to happen, I'm not going to allow you to rotate, because rotation being upside down is no good. And also when I rotate it, you can see that this object changes size, so it's really small. That doesn't make any sense. I don't want to support rotation for my project. So what I'm going to do is I'm going to go to File, and I'm going to go to Build Settings. And I'm going to go to Android and switch platforms. When I'm done switching platforms, I'm going to go into Player Settings. And one day. All right. Okay, I wasn't right. There. And then I'm going to go into Player Settings, and in Player Settings, I'm going to go into a couple things. One is the product name. Again, I want to update the product name so it says 3B for you guys. Let's move our version to 1.03 because we're actually adding a player. I'm going to go into where it says Allowed Orientations. I'm going to uncheck Landscape Right and Landscape Left. I'm not going to allow that right now. And in Other Settings, I'm going to scroll down and make sure that my bundle identifier, which is CA George Brown Game 2014, is also updated. Okay. The rest is going to remain as last time, IL2CPP for the scripting backend and the .NET 4.x for the API compatibility level. And I can close this down. All right, so that is going to restrict my ability to change stuff. Which middle step, Kira? Oh, sorry. Build settings, player settings, and inside of other settings, I want you to go down to where it shows your package name and change that to match. And then that's it. For this, I just changed this part, like version 1.03. Okay, just to make sure it matches. All right, cool. So that is my project settings for this. I'm stopping the orientation to move left and right. So it doesn't go landscape, it only does portrait, which is cool. And I'm going to file, save project. And let's start thinking about some code to move my player. So let's go back up here. And I've got a reference to my rigid body, yay. And there's a bunch of updates I can use. I can use update, which is called every frame, but I can also use something called fixed update. And one really great thing to know is you can access the Unities order of execution to understand how updates and all that stuff work. This is for all game objects. I just copied it into your chat. So the order of execution, we could probably put this onto Blackboard as well for those people who are going to be watching that or want to get a link to that later on and are not physically here. So I want to go to build and I want to go to web link and I want to add in Unities order of execution. All right. So what this is just a reference to how Unity's order of execution works. So that means when I look at this, if I scroll down, you can see that what I start off with is an awake function, and then I go to onEnable, and then there's start, and then there's something called fixed update, which works great with physics. It's a fixed deterministic time step like update function, okay? It's not a dynamic update that we get from the regular update that's here, game logic, okay? And it's not also like late update. So there's actually different updates. There's, right? There's fixed update, right? Then there's update, and then late update. Okay, so different kinds of updates. So we want to use fixed update because we're going to be using physics. And what it doesn't allow is it doesn't allow us to spam the keyboard or input, right? So for now, we're going to use fixed update. So going back to our code, I'm going to change this from update to fixed update. And in fixed update, what I want to start off with is some kind of movement function. So let's just do some outlining. I want to have a new movement function, which I'm going to make private. I also talked about the ability for me to stop moving out of bounds. So I want to have a check bounds function. Okay, so I want to call move first and then check bounds. Okay, so move and check bounds. Let's do the movement first. So for movement, what I want is I want to define a variable x, which is equal to an input.getAxis raw. And I want to use the horizontal axis right now for input. But I'm not using touch input. And this would be a problem because in Unity right now, I have the simulator on, and the simulator will not allow me to input anything unless I'm using touch input. So I'm going to move from the simulator to the game. But instead of using free aspect to simulate what it looks like, I've created a couple of additional aspects. One of them is a portrait that is similar to what the game looks like in the simulator. So the way I've done this is I can go to plus, and you can put in the width and height of your fixed resolution. So you put in 1440 on the X and 3040 on the Y, rename it, call it portrait, and press OK. And then you'll have the same orientation I have, which will also limit you and be very similar to what we're doing here. We need this to happen, or else if you try to get input from your A and D keys while we're prototyping, you won't be able to do that. You'll need to use touch input, which we'll handle another time. Right now, that's not the point of today's lesson. Today's lesson is object pool. Let's just make it work, and then we'll get back and figure it out later. All right, so going back to our code then, now that we know that this is going to give us a value between -1 and 1, where -1 makes us move left and 1 makes us move right, what I want to do is I want to use my rigid body to add force, and I want to add force in a on the horizontal direction. So a new vector2 object, which I'm going to use the x that I'm going to get from my input multiplied by my horizontal force, whatever that happens to be. And then I'm not going to add anything to on the y-axis at all. Am I missing something? I am. This should be in here. So we haven't really defined my horizontal force. So let's start off with a force of, sorry, I'm just going to shift over here and go back just to be able to shift back and forth. We want to start off with a force when we add in our code. Let's just drag and drop our player behavior onto our add component button. And notice that we have horizontal force. Let's add a force of 10 to start, just to have some kind of force that's going to be added to our object when we move. So that's what this is going to do. Add force, going to add force to on the horizontal. But when I play it and I move around, right, you can see that it's a lot and it goes off screen. Right, kind of zooms, and I can add force so I can like really speed off the screen really fast. I want to limit it in terms of speed, and I want to also limit it in terms of our boundaries. So yes, I could use a clamp, and some people have used a clamp before, but I want to create a boundary. But first what I want to do is I want to slow things down. So let's do something like a rigid body dot velocity. And what I want to do here is I want to times equals my rigid body velocity by something like what Alex showed us in the very beginning of our, kind of in your game fundamentals, a little trick hack, kind of a hacky way of slowing things down at 0.99. And this is okay. What it'll do is it'll slow you down when you're kind of adding force a little bit. So it won't allow you to, we could do that too. But you can see now eventually it's going to slow down, okay? But yes, we could put linear drag. The suggestion is to put linear drag on our rigid body as well, okay? I'm just showing you another way. Yes, you could do it, totally do that, absolutely. Okay, so, but instead of a rigid body velocity, what we really want to call this is some kind of velocity decay. And so the suggestion earlier today was to, just to keep it the same, is to make some kind of decay value. So again, we'll call this public float, we'll call this decay. And instead of us multiplying it by 0.99f, what I want instead is to say, let's take 1.0f, and I want to subtract our decay value. Whatever that decay value is, multiply that by the velocity, so that'll slow us down, whatever that value is. Going back to Unity now, what I can do is, in the decay value, I can put a value in there, but I don't want to go higher than 1, so it should really not allow me to put values greater than 1 or less than 0.0. So I can stop that from happening by, at the top, I can say I want to limit it with a range. I can say that I want a range, as an example, of a minimum of 0.0 for my decay and a maximum of 1.0. When I put the range in here, what happens is, if I go back to Unity, then you're going to see that the range now, or the delay, the decay is a slider, as opposed to just a number. So we can put in something like 0.1. And if I press play now, you can see that I get quite a bit of a decay, right? And it might be too much. So let's try something like, I found 40 was a good number from earlier. It's a little bit punchy, and it gives me a little bit of a delay, right? Try that out. All right, so that kind of handles our movement, but it doesn't stop us from going out of bounds. You can certainly use something like a clamp. Some people suggested mathf.clamp. You can do that. But I'm going to make a brand new class to show you how that can be done. So I'm going to go in here and let's add actually a struct. So right click, I'm going to create a new C# script. We're going to call this bounds. And our bounds object, instead of it being a class, we don't need mono behavior in this one, and we don't need these things, and we don't need Unity Engine at all. So let's get rid of Unity Engine. Instead of it being a class, let's make it a struct. And we're going to have two public values, a public float that is the min, and a public float that is the max. So min and max. And you're going to say, wait, we need to system.serialize, by the way. Once we create this little struct, as an example, what's the difference between a struct and a class in C#? Does anyone know? We know what a difference between a struct and a class is in C++, but what about in C#? What's the difference? Kira says struct is passed by value. Absolutely. And in C#, they're all private unless you say otherwise, right? Classes and structs. But in C++, it's not a passed by value, passed by reference. They're identical for the most part, except that struct is public, class is private by default. And there's a convention. We use structs for like little, almost like fields. We want to make our own data type, a small little data type that's combining two things. Then a struct is what we would do in C++. Here, it's the same. Structs are actually a little bit smaller, and from a memory footprint perspective, they're different than classes altogether, but they can do very similar things. All right, so we have a min and a max, and what I can do now that I have that, that bounds struct is I can use it somewhere else. For example, if I go to my player behavior, then what I can do is I can say that I want to have a public bounds object that I'm going to call bounds. And the public bounds object, as an example, by the way, I should probably limit the range of my horizontal force. Let's not make it crazy. So we can say something like, let's make the range of my horizontal force could be something like 0.0 F to 100. So kind of a range, maximum of 100. Maybe make it 200, I don't know. But nothing too crazy, okay? But bounds gives us a min and maximum value. That's what it does, right? So we can say this when I do my check bounds. I'm going to say something like this. I'm going to say, well, when my, so I want to check, first of all, the left bound. And I also want to check the right boundary, right? We've done this before in other examples. I want to say if my transform.position.x is less than bounds.min, then I want to say that my transform.position.x is equal to bounds.min, which limits my boundary. But you can't do it this way because you have to make a new vector to object. And we're going to say that it is, it's going to be bounds.min and on the x-axis, and it's going to be transform.position.y on the other side. So that's how this looks on the left boundary. And for the right boundary, we're going to say something very similar. We're going to say, well, if it's greater than bounds.max, then we're going to say that it is equal to bounds.max, and we're going to keep the same transform position y. So that's your check bounds function. So that'll prevent you from moving off the screen. Now, there's another way to do this that I've seen that works very nicely as well, which is using colliders, right? You can make a collider boundary, and you can basically say that if my object collides with the boundary, it stops. Collision detection instead of using this. Okay, so, and there's other ways too, by the way. So that's cool, but I need to define my bounds. So notice when I created my new struct bounds, it actually showed up in the inspector. And I can say that my bounds, my left bounds is something like negative 1.9, and my right bounds is symmetrical 1.9 approximately. Okay, negative 1.9, 1.9. Okay, so on that I can put that in there. So so left bounds negative 1.9 and maximum 1.9. Okay. And now let's see how this works. So if I run it, we should be able to have some kind of player movement, which is going to be fairly okay. Right? Won't allow me to do that. I can go back and forth, and it doesn't allow me to leave the screen no matter how much I press it. Okay? Thoughts? Let's show you that again. So if I go back to the code, that's what it looks like. Would you have done it differently? Did you do it differently? Again, you can attempt some stuff to explore. Think about using some kind of an actual a collider instead, where it could collide against it and it'll stop you from moving no matter what you do. Okay. I find though that sometimes colliders work weird and there's a bit of an overlap. as well as they can do really weird stuff in the game. All right, so that is the movement, and we made our own custom bounds struct. That might be new for some of you. We made it so that it's system serializable. Again, it looks like this. So system serializable is something you have to have there, and you need to be able to define a min and maximum value. You could also limit these as well. If you say in your bounds that you want it to be a range of values, you could do that. You could say maximum, you can make it a slider, like some kind of minimum value and a maximum value, but we're going to use bounds, this bounds class a lot, or this little bounds struct. It's not going to just be used for this. All right, cool. Let's put this up on GitHub, and we have player movement at this point. That's fairly okay. Kira, bad? Are you still upset about the physics movement, or is it okay? What are your thoughts? Because you said you don't like really physics-based movement. You're happy? Oh my God. Mind blown. If I can make Kira happy, I'm happy. Cool. Excellent. All right, so let's just do this. Let's save project, and then let's exit. And why I do this because I'm being nice. Actually, I'm happy that you're happy is what I'm saying. Let's go back up to this, and you can see here I'm in GitKraken, and what I want is I want to view changes, stage all changes, and then I want to say, let's put this up on GitHub. I'm going to say added player movement, and just to qualify what I said, it's because I know Kira is very detail oriented, and if I can make her happy, a lot of times to me, that means that it's going to be good for a lot of people. Okay, good, excellent. Let's push this up to GitHub. And detail oriented is good. All right, excellent. So now that I've got this up on GitHub, let's relaunch our Unity. And let's go back into this. Okay, so we've made player movement work, but we need an enemy and we need a bullet before we can actually do the demo. And by the way, I'm building up this stuff so we can reuse this next week as well. So the stuff we're paying for a little bit of work this week so that next week we're ready to go with an example we can work with and we can add to, okay? A little game. All right, cool. So let's do that. Let us go to our, for our player, as an example, I want to be able to add now, let's make the player a prefab, okay? Maybe I want to use this player again somewhere else, okay? So let's take under prefabs, let's drag and drop the player in there. Awesome. Okay, so this is a player prefab now. We can use it in other scenes maybe in the future. And similar to the player, I want to do the same thing with our sprites. Let's select all the sprites this time. We know that the player pixel player ship was 100 to 1 pixels per unit. Let's move all of the other sprites to the same structure, so 50. We also want to make them filter mode point no filter, as well as we don't want any compression quality, nothing, and a plot, which means all of these are going to be big too. Let's now drag in a player enemy drone. And the player enemy drone, you can see, is the right size, and it doesn't look pixelated. I want to grab this player enemy drone and put it at the exact opposite end where the player is, at position 4. Okay, so that is our enemy. Let's change the name to enemy. Similar to what we did with the player, I want to create enemy behavior now. Okay, so let's make a new script. So again, scripts, we'll make a new C# script. We'll call this enemy behavior. Okay. And my enemy behavior is going to be very similar to what I've done before. I want enemy movement. So let's do that first. So I'm going to say, let's make a header. And my header is going to be called enemy movement. Okay, I want to add a public. I want to think about this now, actually, a second. I want to do, for my enemy, I want to be able to do some randomization. I want to make it so it randomly moves left and right, okay? That's what I'm doing here for my enemy. You can do it different ways. That's how I'm going to do it. I'm going to make a public bounds for how much my enemy is going to move around. So it's going to be, I'm going to reuse the bounds struct. I'm going to call this movement bounds. And I'm also going to have another kind of bounds, which I'm going to call this starting range. So starting range is going to be where in the scene my enemy will start. Okay. So what I want to have here is a couple of things. Let's show a couple things. One is a public float starting point. I want to show this where that is. And I also want to, these are going to be temporary for now. Later on, we're going to remove them. I also want a public float, which is some kind of random speed. Okay, so those are all the things I want right now. In my start function, what I want is my random speed to be equal to some kind of random range, right? Random range goes from a float minimum to a max float maximum. That's what it does. So random speed is going to be movement bounds dot min and movement bounds dot max, whatever that's going to look like. And then I also want my starting point on the screen, starting point. I'm going to change that. To equals from, I'll do another random range, not random rotation, random range, to go from our starting point dot min start range dot min, well, to our start range dot max. Because those are things that are going to be generated for us. Let's rename starting point to starting point, where it should be. Refactor, rename, starting point. There. So that's what this is going to generate automatically for us. So let's see how this works when I attach this to the player. So again, or the enemy. So in the enemy, I don't have a script. Let's attach the script onto the enemy. So I'm going to take the enemy behavior script and attach it onto the button. And it gives us a couple of things, a movement bounds and a start range. Okay, start range. So the start range is going to tell me where it's going to start from, like -2, let's say, to 2. Okay, what I mean by that is if you look at it, it's about -2.13 to 2.13 symmetrical, right? So kind of to the right there, 2.2, and then to the left around there. Okay, so let's say 2.1 to -2.1 to 2.1, just to keep it symmetrical. So we'll do that. So we'll say minimum is -2.1, maximum is 2.1. That's going to be our starting point. Call it start range. Wow. Okay. And let's rename that. I don't like that. I like starting range. So I have to redo everything again, but I don't care. Starting range. And that means that these are going to change, these values. -2.1, 2.1. When you rename, you lose everything, unfortunately. Okay, cool. So -2.1, 2.1. And then from a movement bounds perspective, how far do I want it to move? I want to go from, like, a -1 to 1. -1 to 1. So if I did this, -1, this is different than what I did earlier, to 1, it's going to have a bit of a play. It's going to go from anywhere in here. And it's going to be randomly moving. Like, in other words, it's going to start off and it's going to say, my starting point is going to be a random number between -2.1 to 2.1, and my random speed is going to be based on my my movement bounds. All right, so that's what this is. And then what I want to do is, in my update function, I want to use my transform dot position, I'm going to say that's equal to a new vector2 object. And in my new vector2 object, I'm going to use something called math.pingpong, mathf.pingpong. And what pingpong does is it takes a t value. So it's actually like a lerp. It lerps between my t value and the length. So I can say something like on the x-axis, it's going to move between time.time. That's how it's going to, that's the value that t is going to be. So it's going to go up and down. And then it's going to go to some random speed. But the random speed is going to be the position that I'm going to give it. Plus, I'm going to add in this starting point. And then I'm going to keep the transform.position.y. Whatever the original transform to position.y was, I'm not changing that. So what this does, the mathf.pingpong, let's take a look at what that does for a second. If I go up, pingpong, what it does is exactly what it shows you here. It says returns a value that will increment and decrement between 0 and length. Okay? And pingpong requires the t value to be self-incrementing, for example, time.time or time.unscale time, whatever you want. And that's the pingpong value. So it's going to go from negative to positive. Yes, I want that. I want the, so Kira says, problem is it's going to be off screen sometimes. Yes, I do. I want it to be off screen sometimes. So it's going to kind of pop into screen and pop out of the screen sometimes, depending on the randomness that I'm going to go into. So some enemies will actually be in the screen. Some enemies will be a little bit off the screen, will come into the screen and come off the screen, right? So that'll be difficult for you to kill them. Well, not difficult, but makes it more challenging. You have to time yourself. And we'll do the same thing for up and down eventually as well. But for now, all I care about is on the horizontal. Okay, cool. So let's see if this even works, if my idea is going to work at all. And let's see what these starting values are. It's going to give us some values. I'm actually outputting these starting point and random speed just to see what they are without using a debug.log. Okay, let's try this out. And if my enemy works, then we'll see some kind of motion. All right, so that is not expected, right? So I have a starting point of negative 1.6, and I have 0.25 is my random speed, and it's not moving. That's bad. Let's try again. Okay, that's good. So again, negative 1 to 1, right? But I want it to be better, so we can change the bounds of the movement. Let's, again, I want to do a couple things. That's more like it. That's what I want. So kind of like a bit of a range, right? If you want it to be stable, again, you can, this is the random speed. The speed is how far the number is going to be, right? So maybe what we want is 0 to 1. Let's try that. Instead of negative 1 to 1, let's go 0 to 1. And let's see what that does for us. So 0 to 1, we'll get a starting point, and then we'll add 0 to 1. And that kind of gives us a value anywhere between 0 and 1. But you can see that the starting point is different than the other one. So let's try that again. Right? Awesome. All right, so now we can hide starting point and random speed. So let's do that. So we'll say these are private. So we don't need to see those anymore. They're just generated. And we have a pretty good enemy. So let us pull the enemy into our prefabs folder. Actually, before we go into that, one more thing. One thing that the enemy doesn't have, and neither does the player, is any kind of collider. Let's add a box collider. So I'm going to say box collider 2D for the enemy, which is pretty good. It's not terribly amazing, but it's not bad either. And in the earlier example for today, now I can add it into the prefabs folder. My player also does not have any kind of collider, Okay, and that is a problem. So there's a couple ways to do that. I can add it here, or I can add it here. And I recommend doing it here in the prefabs folder, then it'll affect my player. So I can add in add component, and I can add in a type of collider. Now there's different kinds. Some people suggested we use a capsule, but if I use some kind of thing like a box collider, it's going to be pretty bad. Because if I look at the player itself, if I double click, it'll take me into prefab view, and you can see that the prefab view is kind of wide for the collider. Let's move the and so this is one option, but I recommend we do something else. We can use other types of collider 2Ds. The other ones are circle. Again, I can change the radius so that the radius of the circle is pretty good. And we can look at the X offset so it's kind of in the middle, right? So 0. But then what happens is the wings get clipped, right? I can use, yes, Kira, a polygon is what I want to do. But some people also suggested a capsule, and they say, well, what if you turn the capsule horizontal? You know, well, that kind of is okay, but it's not perfect either because you have this area here and area here. Could I make this better by kind of making the capsule a little bit more compressed? Yes, but then you miss some of the tops and the bottom. Not a great solution either. And we could also add a Polygon Collider, which is actually pretty good. Problem with the Polygon Collider, it's more computationally expensive than any other kind, but we only have a ship, nothing else, so it's okay. And if we're going to do that, then we might as well tailor it even more than what this is already. So with a Polygon Collider, what you can do is you can add more points. So that way you can tailor your objects so that they're almost exactly what you would expect them to be from what the shape of the object is more accurate. Now the question would be, do you need this much accuracy for the cost? Because this is a very computationally expensive object. A mesh collider is really what you're doing here, compared to using something that is less computationally expensive, like a box collider. Again, not terribly bad. It's only one object, so it's not like it's going to break the bank in terms of functionality, but you want to keep it so that it is as symmetrical as possible that you can do with your eye. Not bad. Okay, and again, if you want to make, I think the wing here is a little bit bigger, so we can make it so it's the same. There we go. So that's a Polygon Collider, and that's pretty good. So it's a better collider than we had before. Now what we want to do is I want to take this Polygon Collider and move it up. We can do this in prefab view. If I try to do this in hierarchy view, it would give me a notification that I'm going to break stuff if I do it this way. Here I'm not breaking anything. I'm just keeping it the same way. And you can see now that the player itself has a Polygon Collider 2D. Cool. So player and enemy prefab. Let's see if I pull in an extra enemy prefab, what happens? Well, the great thing is it picks a random location, right, when it comes into play. And now you can see one that kind of vibrates a little bit, right? And the other one kind of crosses over. I can bring in as many of these prefabs as I want, right? And to provide more variation to where, hopefully, where they're going, right? Now, I'm a little bit concerned of where they're clumping, right? They should be also clumping on the right-hand side because I'm saying that the starting position is still supposed to be from anywhere minus 2.1 to 2.1. Okay. And that kind of worked out, right? So I don't care about the overlap right now, but you can see that they kind of work in a little bit differently than anything else. And this will provide some challenge when it comes to the bullets that are going to come out of them later. All right, so let's put in, let's say as an example, 3 enemies for now. And I'm just putting them in. I'm not actually generating them with code. Later on, I will. Questions so far? Good, excellent. So let's go into File, Save Project, and then Exit. And what I want to do again is use Gitkraken to view my changes, stage all changes, and say added enemy. Cool. And back to the game. All right, at this point, I want to say, are you with me? Are you good? So check mark if you're with me, X if you're not. Pretty simple example, player and enemies. Carrier good. Anyone else? Herman's good now. Excellent, Herman. Megan, good. Eric. My player never got the player behavior script. You got to drag and drop it on it. So under the player itself, you can drag and drop it on there. All right, so now that we have our enemy, I'm going to go right till for another 5 minutes. Let's make our my bullet, and we'll take a short break. So I'm going to use this enemy small bullet. It's going to look like this. It's kind of cool, right? And my enemy small bullet is going to be the one that's going to come down at me, right? So let's move it around. Let's call this enemy bullet. And the enemy bullet, I'm going to use just going to move it to here to start off, just to test. And what I want to do is when the bullet is instantiated, we're going to have a bullet behavior. So we're going to call this bullet behavior. Menu script. When I double click onto it, let's think about what this bullet behavior script is going to do. Okay. So really, again, what I want to do is think about a couple things. How fast is the bullet going to come down? And what about the bullet bounce? Okay, I want to be able to do that. So I want to have, just like we did before, some kind of move function and some kind of check bounce function. Okay, I want to be able to do both things. So let's do that. So I'll say a fixed update. And I'm using a fixed update for a fixed time step for how I'm going to move in a second. And I'm not going to do coroutines today. So I'm going to do coroutines another day with you guys again, because a coroutine might be a good delay as well. I'm going to use different kinds of delay here than we've done in the past. All right. So what I want to do is in fixed update, I want to have two functions. So private move function, like I did before. And a private check bounce function. So when the bullet leaves the kind of the screen, it gets destroyed. Okay. So in order for me to do a move and check bounce, it's very similar to what I did with the player, right? Move and check bounce. The bullet's going to be able to be more dynamic in some ways than the enemy. So what I want is for some variables. Let's talk some variables. One of them is going to be a public float, which is going to be a speed. And I want a public bounds, which is going to be called bullet bounce. Okay. And again, this is all going to be about a header with bullet movement. Okay. Start function I don't need yet, but I will in the future. And I got to think how the move function works. So what the move function is going to do, it's going to say transform.position. I'm going to subtract my new vector3 object, which is going to subtract nothing from the x, but it's going to subtract speed from the y and nothing from the z. Okay. So every frame, it's going to go down the screen. This is very specific to a downward motion from the bullet. You may want to be thinking about how I'm going to change the script in the future to allow upward movement and a different kind of bullet. If I have a different bullet, it's going to move up compared to this. So there's some other way we can modify this. And then in the checkbounds function, we're going to say something like if transform.position.y is less than my bullet bounds.max, then what I want to do is I want to destroy this .game object. So it's going to destroy itself. Okay, this is the non-bullet manager or non-bullet pool bullet right now. Eventually, we're going to do something different than this. All right, so that's the bullet. And let's add this behavior to the bullet itself. So again, I've got my enemy bullet. Here it is. And I'm going to take bullet behavior and drag and drop it on there. And the speed for the speed, we got to think about what that speed is going to be, right? So we don't want it to be too fast. So something like 0.1 would be okay. But instead of me allowing the user, whoever uses my bullet class, to change the speed to radical numbers, because it's going to use a fixed update, we may want to limit the range. So going back to the code, I may want to say that the speed is going to have a range of values between something like 0.0f all the way to 0.2f. Let's say between 0.0 and or 0.5, nothing more than that. Because this is parts of the screen, like units right now. That's what we're doing, okay, for speed. Parts of the screen. Okay. Cool. So if I run it now, 0.1. Oh, my max boundary, I need that too. Max boundary would be if I took the bullet and went all the way to the bottom, it's got to be beyond something like this. When it leaves this part of the screen down here, right, if it goes below, so that's something like -5. Let's say -5.5, just to make sure it's completely off. Once it goes to -5.5, then the bullet destroys itself. And the minimum position for the bullet would be something like this at the top of the screen, which would be something like, well, maybe we want to start the bullet raining bullets like off screen, like something like this. So we can also say maximum is going to be 5.5. So a nice range again. Okay, so that's how the bullet's going to come down. Let's test it to see how this works. So again, I'm going to save scene and press play. And if we did everything right, then the bullet should stream down the screen. Good to go. Okay, and the bullet should destroy itself as well. Notice that the bullet disappeared. So let's try that again. So again, when the bullet came on, you see the enemy bullet, but as soon as it leaves the screen, then it's gone. Okay, old style bullet. Okay, great, that's good. Enemy bullet. Let's go into the prefabs folder and drag and drop the enemy bullet in there. Ooh, before we do that though, hold on. One thing we're missing is let's add in a box collider, because the bullet should have a box collider as well. Okay. If we added a box collider in here now though, what will happen is if it hits our ship, it actually moves it, right? So the type of collision we want the bullet to have is not a regular collision, but rather a trigger. Cool. And we're going to think about the trigger collider for our ship as well. These ones, though, our enemy, right? They actually use a real collider. And maybe what we can do is later on, we can make them so that they can't overlap and they kind of bounce into each other. All right, let's put our bullet in the prefabs folder right now. There we go. Awesome. And this is a great place to stop and take a short break, right? We're kind of at the halfway mark, right? 3. Yep. Because we start at 3 and we go to 6. Yeah, so we're almost like just beyond the halfway mark. So let's take a short break and put this up on GitHub. Let's remove the bullet because we're going to generate the bullet here. And file, save project, and let's put this up on GitHub. And then we'll take a short break. Added enemy bullet. Awesome. All right, any questions before we take a short break? We're going to take about 10 minutes. Well, let's say not even. Let's say 5 minutes. We'll come back at 5, and we'll finish off the day with a bullet pool. All right, cool. So I'm going to stop recording on YouTube at this point, and then we'll record the second part, which is the bullet pool, after the break. Awesome.